Hi, my name is Vince Kelly. In preparation for the CiscoLive seminar that I'm going to be doing next week, the DevNet2645 session on writing multi-threaded and multiprocessing networked applications in Python, I wanted to take all the concepts that we're going to be talking about next week, and really all the concepts that we've been talking about over the previous CiscoLive DevNet sessions on networking, writing networked applications, pull them all together into one kind of tangible demonstration. And that's what I've done here. What I've done is I've built this RAT malware example demo. And a RAT is nothing more than a remote access Trojan. And we'll get into the specifics around that. But with that, let's kind of jump in. So what I did was I found out on Git an analog clock. It looks like it was written by someone by the name of Andrew Owen back in 2012. And really all it does is it looks like it was a part of Andrew's comp sci class. What he did was he created this real-time analog clock that just, that the hours, minutes, and second hands advance as it runs. And he used Tkinter to do that. So it's based on, it was 2012, so it was based on Python 2.7. So the first thing I had to do is convert it into 3.6 in order to run it. I've also put the link out to GitHub where Andrew's code still sits. So what we're going to do is we're going to show Andrew's code how it's supposed to work. And then we're going to show, on top of that, we're going to bring up our malware code. So before we do that, sometimes it's easier to be destructive than it is constructive. This is a quote from really one of the unsung geniuses of the 19th and 20th century. And really, it's the entire point behind why we're doing this demo. In addition to understanding concepts behind concurrency and locking and all that kind of stuff and the language, we want to point out that, hate and ignorance just don't work. The damage that's done by the hacker community can be overcome by awareness, by caution, but just by understanding, by knowledge, the spread of knowledge. And again, that's the purpose of this video, is to spread this awareness and sensitivity. Now, that being said, the demo that I'm going to show, the malware that I'm going to run, is running while my antivirus program is running. So does that mean my antivirus program is broken? No, it's a very good antivirus program. It's doing what it's supposed to do. But the point here is today, the tools and the ease of which this stuff can be put together, again, is so easy that there are a million ways to circumvent an AV program. So again, the cautionary tale here is, be very, very sensitive to, what you download. The application, make sure it does what it's supposed to do. Make sure if you download code that it does what it's supposed to do. Sandbox it. Again, just be sure. I showed this to my daughter and it really kind of, she raised her eyebrows when she saw it. So with that, let's move on. So in light of that we're at the end of the day, this is really about writing concurrent programs in Python. But more importantly, at the end of the day, we want to make sure that we constrain this code. So I've gone out of my way to cripple it as much as possible. It's going to be annoying in how we present it, but I don't want this getting out into the wild. So what I'm going to do is, first and foremost, we're going to run everything from the source code itself in the Python interpreter. So we're not going to compile it into an exe. All the text, any text that I want to display, I send it to the shell so that it's fairly obvious something is going on. If someone misuses this code and installs it in someone who's unaware that it's running, I want it to be very, very obvious. I also want it to be extremely noisy. So I used an unreliable transport protocol. I used UDP between the endpoints. I want to make this as noisy as possible. So if it is misused, any organization that's running an IDS or a SIM will be able to pick out the behavior pretty quickly and take action. I only use the IPv4 protocol stack because if someone is going to misuse this code, they're going to have to hide the behavior. And one way that hackers do that is by encrypting the payload. So the reason I used only IPv4 for this is if they're going to try to misuse the code, they're going to have to take the extra step of building crypto into this program, which is not extremely obvious how to do.
So at least it'll slow them down. So also install a warning message when the malware starts up. The user has to click on install the virus button in order to make anything work, to make this demo work. And I make sure that when I grab the camera, that I turn on the camera light as well, so that, again, if this gets misused, gets deployed into someone's machine that is not aware that there's malware running, it will be fairly obvious when that light lights up. I've fixed it so that this only works on one machine at a time. I don't want this thing kind of misused and turned into a botnet, a covert channel, where I have a covert channel running in some server and some zombies. This turned into a bunch of zombies. And again, most importantly, there is absolutely no error correction whatsoever in any of the code that this runs on. And I've done that on purpose. If you fat finger something when you're entering in an IP address or anything happens out of the ordinary, the program will crash. And again, that's done on purpose so that, again, if this gets misused, it becomes fairly obvious fairly quickly. And then also, the other thing is, when this program runs, at least on my machine and the machines I've tested this on, it degrades performance pretty quickly. In fact, I put in some timing logic, and I'll show you some of that as we go through this. But it does impact system performance, and again, it become fairly obvious. So let's look at our physical environment, how we have this set up. So we have the victim machine, and it's going to run a program called Analog Clock 36. And what we've done is on a Ubuntu Linux server, a VM that I've pulled down, I've installed this rat server called Evil Server 36. And what I'm going to try to do is clean this VM, this virtual machine up, and then load it up to this Python repository that I've built over, the past couple of years. Hopefully I can get that done before the seminar, but in any case, at one point I'll have that up there. And when it's up there, the username and password, I'll just leave it as user and user. This is pretty much unpatched, unsecured, so use it at your own peril. So in order to show the quote-unquote air quotes here, platform independence, I've also taken the same evil server code and deployed it on a Windows machine as well. And you'll see that they both run exactly the same. Now, this is my final fail-safe mechanism for making sure this code doesn't get out into the wild. This is only platform independent if I have the appropriate libraries installed on the machine. So, and I'll point those libraries out. If I run Evil Server without the libraries installed on this, it will crash. It will not work. If I were to compile this with those libraries, I would create a portable version that would be platform independent. But again, this is kind of a fail-safe mechanism to prevent this from getting out. So how does it work? So we've got my Windows 10 machine. I've got a keyboard. What I'll do is we'll start up Andrew's clock to show how it should work. And then we'll start up the analog clock 36. And what that'll do is that'll spin up Andrew's code, show the real-time analog clock. And in background, it'll spin up 3 threads, a keylogger that chains itself into the keyboard interrupt handler, a key sender, and a screen capture thread. In the meantime, I'll also start up our rat server, our Evil Server 36. And that's going to spin up 3 independent threads. But it's also going to spin up or create a FIFO queue. And we're going to talk about this in a minute. Now, let me step back. One of the things that we're going to talk about next week in the seminar is multi-threading in and of itself. So what happens is in Python's a pretty old language, and they never expected we'd be using it in the ways that we use it today. So when we talk about quote-unquote independent autonomous child threads, they're not really independent. What Python does is it's got something called the global interpreter lock. And what it does is as a thread comes up, it grabs the GIL, it spins, it releases the GIL, the global interpreter lock, and then the next thread in the queue or the next thread in the execution queue is going to try to grab that lock. If the lock is not there, it means somebody else has it, and it has to idle until it can find that lock. Okay? So how does it work? So keylogger, again, it's chains itself into the interrupt handler. So when somebody hits a key on the keyboard, it's going to pass that character into the operating system, but it's also going to take that character and dump it into a buffer. And that buffer is nothing more than a simple Python list. And the other topic that we're going to talk about next week is, when to use a list. And, there are times to use a list and there are appropriate times to use a queue, what have you. In this case, what we're going to do is we're going to take each character, and again, we're going to pass it in the operating system, but in the meantime, we're going to dump that into analog 36 buffer. We have another thread spinning in background that's going to sit looking at that buffer and waiting for somebody to hit the enter key. And the reason we do that is I figured that instead of sending each character one at a time, what we'll do is we'll let the characters accumulate in this buffer until someone hits the enter key, at which time I figured we'll probably have a whole line of what the user entered, the victim entered. So they spin through this little Python list. They see a enter key, and at that point they block that up and send it out UDP port 51005, and I've hard coded this, by the way, through evil server to this background thread that's running called key capture. And what key capture does is it just prints it out to the Python idle shell screen, so you'll see what the user is typing remotely. But the malware also, in the meantime, while it's doing that, it also dumps that string onto this queue, this FIFO queue. And what happens here is I have this other thread that's spinning in background, and all it's doing is checking the queue to see if it's empty. It just keeps spinning. Is it empty? Is it empty? Is it empty? The minute something gets put out onto that queue, it pops that element off the queue and then dumps it into a file called capturekeys.txt. So how does the video piece work? So the very first thing that we do is we grab the camera, but when we grab the camera, we make sure, and this is the best I could do for a light, we make sure that the camera light is turned on so everybody is aware. We want to make this as transparent as possible. That video stream is then sent to the background thread called screen capture, which blocks up the stream to a certain size such that the block itself is basically a representation of that screen, the same dimensions as that screen. And then what it does is once it gets a screen of data, it sends that, again, over this unreliable UDP separate port 5005, to a screen capture thread running in background on evil server. And that just dumps the screen out so you can take a look at it. So that's basically how it works. I'll break down in subsequent videos, I'll break down how each one of these elements work, the individual threads. We'll look at the code, what the intent was behind it, et cetera, et cetera, et cetera. But in the meantime, I just wanted to get this demo out to before we get into the seminar next week. So let's jump into the demo. First let's look at Andrew's code. So here's Python 2.7. Here's his code. By the way, I have absolutely no idea how Andrew's code works. And that's one of the points behind this. Hackers don't necessarily have to understand how everything is put together. All they have to do, and all I did, was figure out the appropriate entry points within the program where I could integrate my malware code into. So let's run this and see how it should work. Let's start his code. And here you can see, here's his analog clock, real-time clock. And as he clicks off the second, he displays it to the screen. And really, that's it. Hope he got an A. So now, that's Andrew's. Let's fire up our evil code. And here are the libraries that I talked about. Anything that I did, any changes that I made to Andrew's code, I tried to put a comment next to it to show, just as a kind of a teaching tool. So you're going to need these, in particular, you're going to need these three libraries. They're going to have to be downloaded and installed on your machine because, again, I'm running this source code through the Python idle interpreter in real time. So it literally is going down and executing each line of code as opposed to compiling this into an executable, including those libraries in the executable, and having a platform independent piece of malware. So let's fire up. Well, first let's go over to the other side. Let's bring up our evil server. So again, this is the Ubuntu 1804 LTS, and the user, its username is user and password is user. So what I've done on this is, let me shut this down. I've installed the idle interpreter, the 3.0 idle interpreter. So to start it up, all you have to do is start up idle. Brings up the idle interpreter, and I've dumped really all of the code from previous DevNet sessions. This is the networking code, and the evil server code out here. So you can take a look at those as well. So let's bring up the code. Get rid of this. It's going to come up again anyway. But here we have, again, this is our evil server. Try to comment as much as possible in this. And I've hard-coded as much as possible. I've done that on purpose, so it makes it difficult to move this thing around. So let's spin up. Again, this is a little Tkinter program, so this may help you understand if you're interested. I've written this such that it shouldn't be too difficult. If you don't want to learn Tkinter, you can pull out the Python code that runs without it. But if you want to learn it, I put some additional stuff in here that might make it helpful. So what we're going to do is, again, you can also run this on the same machine as long as you have the appropriate libraries installed. So I can run it using the loopback interface. In this case, I'm going to say no. And I happen to know that the Ethernet interface on this thing is IP address 192.168.1.167. Now again, if I had fat fingered that, it would have crashed. Here's our little Tkinter piece, and really all it does is, if you want to shut this whole thing down, you hit the shutdown button. It will show you, it's a little primer on how to put GIFs. This is a GIF, how to put JPEGs and PNG files, embed them into a Tkinter program if you're interested. I also created a little JPEG resizer if you want to use it, take a look at it. But that aside, if you look at this, this is pretty clear. I mean, it's line by line, but look at this. This is a mess. So what's happening here is these are we can see the individual threads spinning up. And this is classic kind of thread considerations. When each thread comes up, I have it print something to the screen. And when it grabs that screen, it believes it's the sole owner of that. So it's going to dump, those threads are going to dump whatever they want to print right on top of each other. So it looks a bit confusing, a bit muddled, but we've done that on purpose. All right, so let's put this guy aside for a second, and let's go spin up the analog clock, the malware clock. So first thing we get is a warning that, put my clock over here, Andrew's clock over here. First thing we get is a warning that just want to, again, make this as readily apparent as possible. And we're going to get, again, the 127. Do I want to use the loopback? I want to say no. And I know that the rat server is at 192.168.1.167. So hit enter. There's Andrew's clock spun up. Now notice none of the threads is spun up. Andrew's clock is still running. The only way to fire this up is, and again, I want to make this as apparent as possible, is to hit the install virus button so that everybody knows what's going on here. So let's fire this up. So you can see the threads start spinning up. There's my background threads running. Now let's do this. Let's bring up Microsoft Word. And what we're going to show is the keylogger portion of this. Hello from Microsoft Word. And let's do this. Let's also, let's fire up a couple of things to show the irrelevance of, now that I'm chained into, now that I've grabbed the keyboard interrupt handler, I'm hooked into that. 1, 2, 3, 4, 5, 6. And again, these characters are just being collected in a buffer. Nothing's going to happen until I hit the enter key. And it doesn't matter where I do it. Let's do one other. Let's bring up a web server. By the way, this is the repository. I need to move this to CiscoLive 2019, but this is the repository that I'm going to put everything out, all the code and this demo, these videos, what have you. So for example, these are from previous DevNet sessions. Here's a subdirectory on multi-threading. Here's all the source code you can go through. And even, let me do this. sorry for the sidebar here. Even in the DevNet sessions themselves, I have older versions of the previous. These are all the source code repositories. I have a lab with a couple of VMs, a Hyper-V VM. I have a VirtualBox VM sitting in there. Now, just a warning, the VMs that I put out there are unpatched and unsecure, so use them at your own peril. Here, I put a router out there, and I put a very old version of Ubuntu, some videos on things like how to convert a VirtualBox VM into a Hyper-V VM, how to do it with PowerShell, how to use some utilities to do it, et cetera, et cetera, et cetera. So, and let me just, while we're on this side note, let me just jump back a little bit further and just show you, if you're unfamiliar with Python itself, let me go back to the base directory. What I have here is, in addition to the DevNet sessions, I have a set of Python tutorials. There's about 10 hours worth of videos and source code examples. Here we talk about things like some of the Python utilities that come with Python, how to install Python 2.7 and 3.6 side by side. And here I have a bunch of videos, again, like 10 hours of videos just on various components of Python, dictionaries, lists, strings, data types, that sort of stuff. You can see performance is degrading here. And I've done that on purpose. So let's go in and go www.yahoo.com. And look how slow it is. www.cisco.com. Let's bring up two websites. All right. So now that we have this, let's make sure we've got our headlines. Yep. And this thing is really clunking along here, which is a very good thing. Let's go to our rat server to see what he's doing. And there you go. Here's our video. Now you'll notice I put some slowdown code in the video here, so it's very herky-jerky. It's very, it's kind of all over the place. There are like blocks here. And that's because I'm using UDP and I put slowdown code in here. When I originally turned this on, it literally buried the server. So I'm not going to go through, I'm not going to clean this up. This is up to you to figure out when you get a minute. But that's the video portion. That's the screen capture. Let's look at what we caught behind the scenes. Here's everything that let's go up the screen a bit. Here's us starting up our threads, if you recall. And here is all the stuff that we did. Here's our, hello from Microsoft Word. By the way, you'll notice that we record where it came from, the stream that it came from, and here's its peer socket. So I sent this out on 51005, and he is peered, Evil Server is peered on this covert channel over this peer socket number. Here's the Excel stuff and the various websites that I visited. By the way, if this was your banking application or your email, we'd be collecting your passwords as well. So just be aware, this is dangerous stuff. Oh, and one last thing, let's look at, before we look at the Word session. Yep, here's our captured key file, text file. I can start it up. And again, this is one of the threads that pulls off the character string that we typed in just to record it. I put a timestamp in here. I should have put the IP address in here as well, but again, you get the point. This is the strings that we typed in and the websites and would be your passwords if you type them in. So that's that. Let's shut down the rat server on Ubuntu and start up. Man, this is slow, which is a good thing. That's what we're aiming for with this malware. We want everyone to be aware. So we're going to shut this down. We'll shut down the video portions of it. Really everything else. So now what I've done is, I didn't shut it down the right way, so it crashed. So not going to worry about it. So what I've done is, in running these programs, I've locked up the hardware. So I grabbed the camera, I grabbed the keyboard. So now I have to release that in order to show you this. I have to release that hardware in order to show you it running on Windows. So the other thing I'll point out is, while I'm running the malware, I'm also printing out anything that you do on the key itself, on the keyboard. So, anything that goes on, so that it's absolutely obvious what's going on. So let me shut this down, and I'll release. This releases the hardware. I'll leave this up. Let me go over to the other VM, the Windows VM. Same exact code running on Windows again, but I've installed the libraries here. I'll put a video out on how to install it, but just for jollies, let's run this guy. Here's our obligatory, enter the IP address, 192.168.1.175. We've spun up our threads. We're waiting for our victim. Let's see what we got. There's our Dr. Evil. Just put him over here. So now let's go back and fire up our malware code, analog 36. Let's run this guy. Warning screen. Put this over here. I'll say yes. I'll say no. I'll give him the focus. Say no. 192.168.1.175 is the Windows PC. Again, nothing's happening. I got to install the video. I have to install the malware. So let's install the virus. So you can see the viruses. The background threads are spinning up. Let's I don't know. Let's write something here. A bunch of S's. I'll do it on Word. Misspelled word, that's okay. And you can see in background, I'm just displaying everything that we type in, that we've hooked in. Let's go to Windows and see what we've got. There's our video. You can see the video is a little bit different running on Windows. That's platform differences. Again, you can clean this up. You can also shut the video screen down itself by just entering Q for quit. But what we'll do is we'll just shut everything down. And we're done. And really, that's the end of our demonstration. Let me make sure we've got here's our capture key file that gets caught. And you can see there's what we typed in. And really, that's all we have. I thank you for your time, and I look forward to speaking to you all next week at Cisco Live.